Right. Good morning, everyone. It's about a minute. Okay, a few seconds left, but we shall kick this off. Welcome to the. Okay, thank you. Welcome to the 2021 Data Science for Society seminar series. This year, we have, I think, 6 sessions that we will be running. And I think this is now going to be more of the pattern that we run every year. We just will plan it for the second half of the year, makes it easier for everybody to know when it's actually going on and what to actually expect. It'll be great, just given everybody who's around, just to have people in the chat, just type in your name and where you're joining us from. So which country you're in and city, just to kick us off and just to make sure we're all awake in South Africa. It is 9, it's a little bit early in the morning before I then introduce our speaker. So your name, your city and country. So for me, it's go see South Africa.
Morning, Doctor.
Hey, yeah. Right, so cool. Right, as that is going on, I will introduce our speaker for today. So we've lucky to have, as part of our continuing collaborations, with ABSA. Today we do have Felipe Melo, and he's been at ABSA for the last 4 years. Before it was Barclays Africa, obviously, and then he started in 2018 as a data engineer. And now he's working in the CVM space, which I'll hopefully explain, working in customer engagement and retention, and currently focusing on automation of internal processing and applying computer vision for automatic document understanding. He's worked in audio processing, recommender systems, web mining, and distributed computing. So welcome, Felipe. Just for everybody, just to know, obviously, we do record these, and these will also become available later on. For viewing online on our YouTube channel. I'll share the links later on. So thank you, Felipe, and over to you.
Amazing. So thank you very much. First of all, can you guys hear me well?
Great. Yeah, I can hear you.
Amazing. So thank you very much for having me. It's a pleasure to share what we have been doing in our team. And I'll jump straight into the presentation. I will turn off my video though, because my bandwidth here is not the best. Okay. And the idea here is to speak a little bit about how artificial intelligence has been playing together with marketing in banking, but I think it's true for pretty much every big industry, or especially the industries that are not that do not have technology as part of their core business. So I will tell you a little bit about the opportunities that we have, where we are in with our team and ABSA as well, and where we are heading, which means that I will be talking a little bit about future projects. Before I get into the main subject, I'd like to let you know a little bit about myself. So yes, as Dr. Vukosi mentioned, I'm currently a lead data scientist at ABSA Data Solutions team. So we develop solutions for CVM, which means customer value management. So it's basically engaging and focusing on engaging and retaining customers. And previously I was a data engineer also at ABSA, and when it was still Barclays. And I'm from Brazil. So back in Brazil, I co-founded a company called Soundview Limited, which basically was applying audio analytics to radio marketing. So we identified spots that were playing on radios automatically. And then we generated analytics on top of that. And before that, I was developing recommender systems at Idealis Labs, which was hosted at Federal University of Ouro Preto. Actually, Soundville was a spin-off this lab. And before that, I was a software engineering consultant for Petrobras. Petrobras is the largest oil company in Brazil. So it was basically information extraction and calculation of risk. This is a little bit about my background. Now, about the talk today, the agenda is exactly this. I will first present what I believe to be some opportunities that are unique for banks or big institutions, and also the times that we are going through, and then the challenges to make those opportunities come true. So we need to overcome them first. Then I speak a little bit about the approaches that we have been taking to overcome those challenges and what we have been getting as a result. And of course, the results bring new problems. So I speak about those as well, and then what we are going to do about them, because it's kind of next steps. So starting from the opportunities, I wanted to present it very quickly, just to show the different fields that can benefit from artificial intelligence inside the bank. So there is this study from McKinsey, and they have run some case studies, and they have identified, as you can see on the bottom left, that marketing and sales, they have the biggest potential for increasing revenue when it comes to AI. And then they are dividing AI here into fields. So you have a traditional analytics and you have advanced AI. So this is just to show the potential in general, because it's kind of um, an untapped field, and I'll let you know why, because it doesn't initially it doesn't seem to be the case. And now talking about the position of banks, so that we are able to realize those opportunities, especially in the marketing space. There's much more in terms of risk and regulation and automation of internal processes, but this one is about marketing. So first of all, we have been gathering data for decades, because banks, they play at the very edge of technological capacity, because they have the resources to do that and they want to keep an edge. And of course, as time goes by, we know that the increasing data flow, like we have an increase in data flow, and it will always be unprecedented. So right now we have this huge influx coming from different channels. So you have it coming from not only from ATMs and branches anymore, but especially from apps, web banking, all of those. Also, this is one of the motivations of AI. We have a substantial decrease in the cost of computing in general, so storage and processing. And because of that, so now we have more data and we have cheaper computing. So the tools and the techniques, the generation of those is skyrocketing. So we see these conferences about artificial intelligence, and we can see how quickly this field is moving, which is great. But maybe the most interesting aspect of all of this is that we have a tech-savvy generation. And one thing is for you to deploy technology. The other thing is for people to use it. And thankfully, we are living in a time when people are getting more and more used to having a tech life, so to speak. And that, of course, generates even more data. So that kind of data is what we are used to calling big data, because it has to do with volume, velocity, and variety. And we have all of that when we consider the previous slide. And one of the best benefits that we can get from big data when it comes to marketing is personalization. You no longer need to produce one product that will fit it all for everyone. Now you can understand how different customers behave, what they want. And of course, that leads to better product fit. And we know that better products will take to happier customers, which will be loyal and sustain the revenue. So throughout this presentation, I will try to reinforce these two ideas, because one comes necessarily after the other. We need to make the customers happier before we can get sustained revenue. And everything in the marketing space is focused on these two variables. Okay, so this is pretty much the opportunity we have, but we do have the challenges, and they are not very easy to solve. So first of all, I don't know if you're familiar with how the corporations work in general, but I will try to explain it quickly, at least the way I see it. So this usually, when you're talking about banks, car makers, insurance companies, government, they rely heavily on mainframes. So mainframes are considered to be the workhorse of IT in the world. For example, more than 76% of the credit card transactions in the world are processed by mainframes. And it's a technology that has been around for quite a while, and it's very effective, otherwise it wouldn't still be around. However, the interoperability of mainframes with other systems is still quite poor. There is a little bit of purpose in that, but they also come from a different era. So this is one issue. The second problem is inside big corporations, you don't have the sectors or the business units talking to one another. So, for example, in bank, you might have investment banking and you have retail banking, and they are different business units. And one does not necessarily access data from the other. And because of that, it's very hard to know which data is available, because you have these data silos. The data is siloed inside that business unit. And because it's hard to unify the whole thing, you don't have a source of truth. And we know that for machine learning, artificial intelligence in general, that is super important. That is related to data quality. So it leads to incompleteness, of course, because if you're, let's say that you're working on the retail space, you can benefit from the data that comes from investment banking, but you don't have access to that. So this is one problem. The data is kind of, the view of the customer is incomplete. Also, since the data is only used locally, the data sets are only used locally, you might have hacked schemas. So someone went there and added a field that should not be there. It's not the best practice. And then this person leaves, someone else comes in and says, okay, the only way to solve this is to hack it even further. So it leads to duplications, all the sorts of problems with regards to data quality. And we know that garbage in, garbage out when we're talking about data-driven systems. And there's a third element here. I mean, I won't be speaking much about it, but it's workforce in general. So talent, it's very hard to find, very hard to retain. And it also leads to a mentality of buying versus building, because if you cannot find the talent, you have to buy your solutions. So since I'm not speaking much about it, I'd like to present just this slide. On the left side, you can see the demand for AI skills across industries. And then we can see the information is quite hungry. So it's tech houses. And then on the right side, you can see the difference in terms of salary. So our industry is paying quite okay, similar to what they pay. However, they require a lot more people. And if they go to those other industries, especially this information industry, the data scientists or machine learning practitioners, they will not face the same issues coming from legacy and issues to access data, as I mentioned in the previous slide. So it becomes even more enticing to go there. So we have to fight for this talent. It's not that easy. But these are basically the challenges, and I'll be focusing, of course, on the technical challenges from here. So now I'll talk a little bit about how we have approached the solution of those challenges in our team. The first thing is, and then of course I'll show examples. But the first thing is we need a streamlined data engineering because we have different data sources. We have those silos, and we need to put the data together to create that source of truth so that we can have a holistic view of all the data that we have available. And one thing that we have been doing quite successfully is leveraging open source solutions. So Hadoop, Spark, Kafka, things like those. Also, those tools, they are not silver bullets. So what we sometimes, and I'll show it as well, there are some gaps in terms of how those tools work and what we actually need to do with them. So we develop tools in-house to cover those gaps, and then we contribute back to the community, and we present in conferences, that kind of thing. But also, one thing that is important from this initiative of streamlined data engineering is that we are improving the quality of the data, because now we can try to consolidate data from different business units. And once we make that available, or once we make that consolidated, we make that also available to everyone. So there is an attempt to create a source of truth that can be used across the whole group. So this is on the data engineering side. There is also the approach on the let's say on the model side. And one thing that we have been leveraging, and successfully as well, I also show, is to use cross-domain feature generation. So we take, let's say, features from transactional space, and we apply that to low-end space. And then we do that across different units. So here is we are answering questions like, can a customer's transactional behavior predict the need for a low one? And can it also predict the propensity for that customer to take up the low one? And we are doing it cross domain, and because we do have the silos, but we are also consolidating it, and we are seeing the results, as I'll show next. And the final thing, which is quite new and is super exciting, is this idea of ML ops. So we have lots of ops nowadays: DevOps, Data Ops, and ML ops is yet another acronym. But we have been able to deploy that, and I can testify, and I will show numbers as well, that show that it actually speeds up and it improves dramatically the time from development to production. So this is how we have been approaching. Let me quickly go through, for example, the data engineering solutions that I mentioned, but this is not the focus, it's just to give you an idea. So this is our open source space. And then we have multiple tools in here that we have developed that have been adopted by the industry. We have tutorials written online about it. We present it in conferences, scientific conferences. Spline, for example, was presented in China like 3 years ago in an IEEE conference. Codebricks is one of its kind. It's a way for you to process mainframe data on top of Spark and Hadoop. So it's basically bringing mainframe data to the open source world. Abris, for example, is a library that will allow you to connect Spark to Kafka to schema registry with a single line of code, because this is how streaming works in these days. So it's about velocity of the data. So this is what we have been doing the data engineering side. So we decided on a stack, and now we are improving it and making it fit our needs. And now probably the interesting thing starts. So this is how we are tackling the machine learning side of it, or the data intelligence side of it. The first thing is we have to produce features. And I will explain in the next slide why we need this kind of feature and why we are not getting straight into, for example, deep learning. But to generate the features, it's not so straightforward. The features need to have some meaning. So here is an example of what we have been doing to identify a client risk. And it was implemented right after the COVID outbreak it was in March 2020. So it started to be implemented from there. So what this model is basically doing is this. it gets a customer, it runs for all the customers, and then it will calculate the average influx and the average outflux of the account, and then it will calculate the variation, the inter-month variation of these influxes, and then it will check how stable these influxes are and calculate exposure, and then it calculates a metric called financial capability, and these financial capabilities fit into a normal distribution so that we can quantify risk, which is the bottom of this table. And one example of one kind of analysis that we can make here is like this. This customer, if you can see in the fourth row, the customer, I don't know if the mouse will work, if you can see what I'm showing here, but on the fourth row in here, we can see that this customer had an average influx of 15,366 rands. That was the average. And then in the previous month, before the month it was this data was generated, the influx, so it is the name of the row is previous influx total. The value was 14,500, which is quite close to 15,366. But then in the last month with regards to when the data was generated, the influx was of 1,125. So this is quite a substantial decrease, but we don't know if it's normal. Maybe this customer is quite shaky in terms of behavior. So we have other features in here. So the other feature is we have average intermonth influx variance, which is just 4%. So this customer is quite stable. So let's say that the stability is 96% because the fluctuation is just 4%. And all of a sudden, there was a variation of 93%. And the same is true for expenses. So it used to be, let's say 15K, and then in the last month it was 18K. So it's a variance of 23%, and it used to be just 1%, as you can see, average intermonth outflux fluctuation. So this is a kind of visualization that we built it mainly for analytics, but we started to use these features to predict those propensities. So it's like investigating the customer behavior from this perspective. Is it something that can yield good results? And if yes, what kind of model should we use? So one information, this kind of feature here is tabular feature. Okay, so what we would usually do is put a bunch of features like this. And then in the end, a binary flag saying, this customer took up a let's say credit card, yes or no. That would be your label. This is an interesting research. And next slide, I will show you how we could basically reinforce it. But what this slide is, what this study shows is, the name of the study is here on the left. It was running benchmarks when the training set is composed of tabular features. And as you can see, you have node, DNFnet, and all of those. Those are neural nets. And we have XGBoost, which is just a gradient boosted tree, is one of them. And they somehow show that for tabular data, you cannot do much better than these gradient boosted trees. Even neural nets cannot do better than that. And actually, if you go to Kaggle, you see the XGBoost is kind of the killer. And it has been actually improved, as we can see here. So this is a result from an experiment trying to predict if a customer would take up a credit card. I was using a library called PyCaret to generate it. But as you can see, it's basically showing you the metrics and the name of the model. And we can see that these boosted trees, they basically kill it. So they solve the problem very nicely. So now that we have the data that was streamlined in the data engineering process, and we know that gradient boosted trees could solve the problem very nicely, and we have means to generate features. So features should have meaning if you use them in analytics as well. Of course, I'm not saying it scientifically, but it's the easiest way to create them. So by having that, we can have a very streamlined process to generate models. And here is a few of the propensity models that we have built. And all of these models have been built in 1 month or less, once we had the data. Of course, some of these models need to craft some new features, and there is the whole investigation phase. But once the investigation phase is done, the data is available in there, and we have an ML ops that will streamline the results. I'll show in a while. But just to explain quickly what these models do. So new to card, we'll try to identify the propensity of you accepting a credit card offer. New to transaction is the same, but it's for you to have a transactional account with us, and then for you to take up an overdraft, or you to become a digital customer, or for you to take a loan, or for you to get your money into some savings and investments. So we have streamlined the modeling of the whole thing by making the data from different silos available. And basically, this is what this next slide is showing. So we have streamlined the whole thing. So we have these different sources, and this is what we have implemented currently on-prem in our team, the CVM space, customer value management. So we have the different sources. They come from mainframes, they come from apps, and they come from different business units. So for example, investment banking, it can also come from cards, it comes from transactional, all of that. And then we have this tool that was developed in-house called Sync Watcher. So this is a data quality plus movement plus ingestion tool. It will ingest all the data into data lakes, into a centralized data lake on top of Hadoop, so HDFS. And then from that data lake, we train models, and then we extract features from the data lake as well. Then we execute the model. And when the predictions are generated, as you can see in here, it's called predictions/Py2K. Py2K is yet another library that we developed and we open sourced. So it's something that didn't exist yet. It connects pandas to Kafka to schema registry, again with just one line of code. So the predictions are sent to Kafka. And then we have another tool that we developed in-house, which is Hyperdrive. I showed you in that picture a few slides ago. It's built on top of Abris, also developed in-house. And the result is automatically collected from Kafka and written into Hive, which is also HDFS, and Hive is SQL compliant. So now we have the business units. So this whole process is automatic. Plugging in a new model is just creating a script for the orchestrator to call the model. So you plug it in here, it's basically solved for you in no time. And the users can start to consume it immediately in a SQL way. So they don't have to fight much against the platform. It's just plain SQL, they already know it. So this is what we have on-prem. And this is our plan for the cloud. So we have pretty much the same. I'm not spending too much time here because it's still a work in progress. But now we are decoupling even further. We are creating a framework to perform, to allow for feature making. So streamlined feature making. If you need a new feature, you just write the code to generate it. You plug it into the framework, and then it gets stored into the feature store. And the boxes, what you have inside the boxes, for example, in the feature store column in the middle, you have SageMaker, Databricks, Iguazio, HopsWorks. Those are options that we have to deploy a feature store. Okay, so, but then we'll be decoupling everything, and the handshake between the data engineer and the data science will happen at the feature store. So it's going to be streamlined and separated or decoupled technically, because we have the different stages playing independently, but also it is decoupled functionally. Data engineers to the left, data scientists to the right. So, but this is for the cloud, this is for the near future. What we have achieved by streamlining and basically deploying what I have just showed you is that on average, our models, they perform 300 times better than random on top K. I need to explain this a little bit better. One thing is for you to have the metrics for when you produce the model. So you have F1, precision, recall, all of those. But then when you send the leads out, things change a little bit because maybe the customer didn't see the message, or maybe the channel was not the best, which I speak about in a few slides ahead. So the kind of metrics that we have, or that we apply as well, is we have the base of customers. Let's say that we are trying to sell credit cards to people. So it's good for them. We have identified it. Now we are trying to sell it. So we draw some samples of customers and say, okay, if we had marketed this product to these, let's say 1,000 customers, and if we pick the best 1,000 from our models, you see a 300% difference, and our model is going to be much better. And that leads to a take-up rate of an increase in take-up rate of between 2 and 15%, depending on the use case. But even though this number might look small, we are talking about hundreds of thousands of customers in here. So if you get 10% of 100,000 customers, and if they accept the offer, that's quite a big number. So this is what we get from the perspective of the results of predictions of the models, but also we have the new models. When they are deployed, they are now taking 1 month or less to be deployed. So we go to a business unit or to a specific space and say, okay, you have a problem. We can probably produce a model to you. Let's understand your situation. And the time between that first engagement and the moment when they have their data available on Hive to use is less than 1 month. Most or all of the work now is being done on the investigation, which is a kind of a dream for data scientists. So they don't have to worry about data anymore, unless they need to produce features. But I think it's quite substantial. And not more importantly, or most importantly, but super important and needs a highlight is this: by delivering new models, we are helping the business to become data driven, because now we have business units that are generating or that are taking business actions based on outputs from AI systems. So this is a big step in the right direction. It was the whole premise of having a data engineering plus data science team inside the bank, is to help the organization to become data driven. This is something that we have been able to accomplish. Now, of course, it brings some problems. We have business problems, and we also have technical problems. So one thing is for the business is how to calculate profitability, because profitability depends on the channel that was used for the acquisition. There's a lot of factors, and also there's time. The customer does not become profitable immediately. There's some time. Calculating that is super tricky. And probably the most important question here is how to retain the customer, keep that customer happy. This is a problem that is the business will ask. And we will ask the same question, but from a technical perspective. So what is the best channel to reach out to that same customer? And I'll explain more about it. And we need customers to keep their marketing consent so that we can keep talking to them. And it's not always the case, I'll show as well. And finally, and it's part of the future, how can we keep feeding data from the new customer's behavior into the model so that we can keep learning about him? And then that would help us to improve retention. So talking about the problems, when we send out the leads, so now we have all the leads, the predictions in that Hive database. If you are talking on-prem, the leads are being sent out. We have all of these channels, or maybe some more. And then the customer is once contacted by SMS, next time it's an email, next time it's a call center, and then he sees the message on an ATM and then SMS again. And let's say that after 6 months, the customer takes up the product. So which of these channels actually triggered the take up? It's an open problem, and it has some consequences if we don't do it right. So the propensity itself faces some diminishing returns in here. As you can see, in this propensity of 40%, if you decide to execute on the leads whose propensity is beyond this point, you have to execute on a lot more leads to get marginally a few more take-ups. So it means that you have to contact more people through these channels. And one thing that we have observed is this. So the green line is the number of transactions, the number of leads, sorry, in the transactional space that were executed. And the blue line is the number of customers with marketing consent. So we can see here very clearly that the more leads we send out, the more customers remove their marketing consent. There's a correlation of minus 77%. So of course, we know correlation does not imply causation. That's clear. However, this number is too big to be ignored. So this is something that we need to tackle. Communication here is key, and identifying the best channel is a right step in the right direction. Also, when it comes to retention, we have the problem of competition, and nowadays we are not competing only against other banks, but we are competing against competitors that come from different spaces. For example, in the payments space, so you have Google Pay, Apple Pay. We have the tech houses jumping into financial services. We have neobanks, like you have Nubank, Monzo, Revolut, all of those that are entirely digital, and we have tech-savvy generations, as we saw in the very beginning. So retention is becoming a problem. So how can we keep being relevant, and especially how can we keep the customer happy? Because this is the most important thing. Because the happy customer is the customer that will be profitable and generate sustained revenue for the bank. So the happier we make the customer, the better it is for us. And one thing that we need to do, and I think it's industry-wide, because we need to learn more about this. It's about personalization at scale. And we have all the data problems that I mentioned. So right now, most of the models focus on take-ups. So we want the customer to take up the product because we believe it's a good product to him or to her. But then after the take-up happens, we do not care about that anymore, and I think it's completely wrong. So we were working on it. We need to keep tracking the customer, understanding their behaviors, and then feeding that information back into model so that the next offer is even better and based on the behavior of that customer inside the bank. So we need to keep learning about the customer. And one thing that I believe is happening, or it's happening right now, if you consider these neobanks, and it's something that we need to start doing as well, like industry-wide, is to go beyond banking. So we can offer credit cards, low ones, but maybe we can also recommend a cafe, a nearby cafe, because the customer is using an app and we know where customers are. So we have a cafe nearby that is a partner of ours and offers some rewards. So maybe we can recommend that as part of the app. So go visit this cafe. I recommend the Cafe X. It's a good return over investment. Or maybe you have a partner that is a travel agency. You can offer a holiday trip with a discount. So we know how customers get their money, how much at least. We know how they spend their money. So we can help them to live an easier life from this perspective, because we have access to that kind of information, but we need to pay attention to their behaviors. Okay, so this statement, I like this statement quite a lot, even though it's a little bit cliched, but I think it's for big organizations like ours that have the resources. This is true that the best way to predict the future is to create it. This is something that we can do. And I think everyone agrees that it would be pretty awesome if your bank helped you to make more out of your money. So maybe this is the way to go. A quick recap. So we talked about the opportunities, lots of data, um, cheaper computing, tech-savvy generation. The challenge, especially in big organizations, is to have quality data. And we explained some approaches of how to get the data together and create a source of truth. And also, once we have that data, how can we approach the problem from a data science perspective? We saw that gradient boosted trees are great and for tabular data, and also how to generate some features that could also be used to analytics. And then what our team has got as a result inside ABSA. So improvement in take-ups and also streamlined process for model deployment and helping the business to become data-driven. But of course, we still have the problem with retention and communication and access. So that we need to tackle by better understanding the customer and keep customers happy. That's the gist of it. And this is basically everything I had to present. And I'm very happy to take your questions if you have any, of course.
All right. Thanks so much, Felipe. That was very interesting. I think, okay, on my side, and maybe speaking to some people, we typically do not get some of the inside views, especially from the banks in South Africa or maybe on the African continent, about actually what's going on in their systems. And this was a good overview that goes through that. Just before I allow, if you want to ask a question, you can just raise your hand, and then I will kind of then note you and then call you out, and then you will unmute after that. Or if you can't speak for any reason, you can also just put it inside the chat. So just to kick us off on that part, on my side, two questions. One on the technical side, as you you have ABSA is a very large bank on the African continent. You have a lot of data on customers. Is it mostly that some of your models tend to be more simpler as opposed to being complex? As a first question. And second one is, as data scientists within a bank such as this, dealing with such customer data and then having to go, in this case, building things like retention or identifying new opportunities, where does kind of regulation and ethics come in for the team, or how is that managed?
Perfect. So regarding the complexity of the models, I'll tell you a story quickly. And can you guys still see my slide deck?
Yes, we can.
Yeah, okay, perfect. So in the very beginning, when we started to create features like these, this is just an example, we started to play with pretty much every type of model. So we tried neural nets, which are a little bit more time consuming, resource consuming. And then kept trying different models. And what we realized in the end was something that the industry, Andrew Ng is someone who has been preaching this for quite a long time. What we have realized is this: no matter what happened, these models here, these gradient boosted trees, they were always solving the problem. And what improved the results was just the data, because the approach, let's say the most widespread approach is the data is fixed and the model changes. So you have a data set, you keep trying different models, and then you get the result, but the results are similar. Now, the other approach is choose a model, let's say Cat Boost, and then try changing the data and see what happens. So when we started to do this, we started to see that the results improved, and we started to rely on the same set of models, which are much simpler than neural nets. So they are also more explainable. So you can have, for example, shape values. I wish I had some here to show you, but you can have shape values, and those will show you information about which features are contributing the most, and they are simple to understand as well. So this is what we have seen in practice in here. You know, keep changing the data, bring more data, take care of the quality. The models will perform similarly if they are from the same family, and they are explainable. On the side of ethics, we have an internal council that is creating, we are trying to create a framework, but basically we pay a lot of attention, for example, to imbalances in the data set, to make sure that when you're training, if there is anything that could be related to ethics in that, so maybe that's related to your level of income, it's an outlier on the lower side, for example, maybe on the upper side as well. So we try not to bias the models by taking care of the distribution of the data and then tracking that afterwards. So make sure that the data is fair. If you have if the data is fair, and if you depart from this perspective that the models will perform similarly, what you need to change is the data. So the output of the model should be fair as well. Did that answer?
Sure. I just wanted to, well, thanks for that that review. It is like, I think it's a bit of a tougher one with the data, because the data, I don't know if it can ever be fair, really. But are there regulatory checks? Again, this is more maybe for general understanding on that part. Like, are there other things that are people who are outside the data science team who then do checks on your final results to assist before it actually gets into, like, you know, full production?
Yeah, perfect. Thanks for that. Yes, there is actually a lot of it. So there's regulation when it comes to the data that we are using. Then there's a lot of regulation, not a lot, but there is regulation with regards to the methods that we are using. So everything needs to be as explainable as possible. And for example, when you try to sell the credit cards or to send out a lead for credit cards, they need to understand where the data is coming from and if they trust that source. And then the model, and I'm not talking about data scientists, it's like trying to explain it to them in a non-technical way, which is yet another challenge that we are facing these days, trying to explain this kind of thing to people that do not have a background in it. So they check the data, they check the modeling, and then we explain to them how which features play a more important role. And of course, we are obliged to pay attention to marketing consent. We should not reach the same customer more than X times through a channel Y. So the whole process is regulated. And the bit about fairness and bias in general, it's usually tackled on the data side. As far as my experience goes.
Okay, thank you. There's a question from Shoki Maketra on the data engineering. He asked, or she asked, I'm not sure, what were the approaches used to break the barriers with the legacy system? Is it just like, you know, you've explained building these kind of new staging processes, but I guess, is there any advice to give on that?
Yeah, sure. So the way this whole thing was done, let me try to also tell a story. It was like this. When the team started, I was not here, so this is what I heard. I took part 2 years later. But it was basically, we were told something like this. You have information inside the bank in mainframes, in CSVs, in relational databases, and some other systems that the bank uses. And we need to create this concept of a data lake because we need to make meaning out of that. And then questions started to appear. Questions like, okay, but how can we, for example, unify the data? Let's say that you have the currency, and in one column it's written rand, in the other column, in the other data set, it's written ZAR. So in the other it's written, I don't know, something else. So how can we make everything just ZAR or just rand? So then we created this tool here. We created, for example, Encelados. Encelados is a conformance tool that will make sure that we can conform that on big data sets. And of course, we had to decide on the stack. So let's go Hadoop, let's go Spark for distributed computing, Parquet for the format, and all of that. And then the question started to appear more and more. So okay, now we can conform data, but we have mainframe, and most of the data is inside mainframe. So how can we process that kind of information? And then we developed Cobrix. So Cobrix can take a binary file from mainframe and process on top of Spark. The next question was then, cool, but we are applying transformations to the data, and then we are generating these models. How can we track the lineage of these transformations? Then we developed Spline. Now we need to send this data to Kafka from these Spark transformations, but we don't have an easy way to do that and to apply schema management. So we developed Abris. It kept going like this. Now we need to ingest the data, but also we need to write the data, and it has to be streamlined. So we developed Hyperdrive. And then once we start to have enough building blocks, you can build something like this. So these sources here, if they are mainframes, they can be processed with Cobrix. If they are relational databases, then it's much easier. So the question is, how can we ingest everything and put it together, in the same format? So we developed yet another tool, which is InkWatcher. So if you have a good idea, that's what too long didn't read would be like this. If you have a vision of what you want to do, check if the tools that you're currently using, if they solve the problem. If not, don't shy away from building things on top of that. So this is what has worked for us. And by talking to other colleagues in the industry, it seems to be exactly the same. So there is going to be a pain. If you cannot find something that will relieve that pain immediately in the marketplace, in the open source community, ideally, so just build that. It pays off.
Okay, thank you. Sorry, are there any other questions or as we start to wrap up? If you have a question, you can either raise your hand or type it in the chat, or we will be closing off. Okay, user, I don't know who that is. There's a question on how do you guys handle feedback loops in your team? One example is once your model is running and making predictions, how do you then prevent it from having bias? I don't know, also this might be drift, and this is Tapelo.
Yep. Yeah. So this is something that we are, to be honest, we are working on right now. This is what I put here as part of the future. So we of course, we monitor drift, and especially concept drift. So we use a tool called MLflow. I'm not sure if you guys are familiar with, but it's an open source tool. It was built by Databricks. So it has it contains the metrics that the model generated when it was first trained. And then as we keep monitoring it, we just keep comparing that with the features that the metrics that we have in MLflow. And then we identify needs for retraining, or maybe there's some drift in the data as well that we are able to identify. But this is work in progress. This is something that we are still trying to implement. Also, because all of this that I'm showing you, so for example, the models that I mentioned here, we have a lot more than this. We have income predictions, expenses predictions, the next best product, the best time to call someone, the best day to collect bills from someone's account. So there's a lot of stuff here that we have done in basically 2 years by engaging with those all of those business units. And it takes time to not to deploy to production, but for the feedback to start. So it's been 2 years, and we are starting to see the feedback now. So when we do have it solved, I will volunteer to come back here and tell you.
Okay, thank you. Yeah, any other questions, or I'm going to close this. Yeah. Okay. Thanks, Felipe, again for this chat. I think it was very insightful. This for me, as I said, is very different. Like, we typically will have some talks that come in from academia, some talks that come in from industry, some talks that will come in also from policymakers. This one was mostly from industry, and really getting to know some of the challenges you guys are dealing with and what you're building. On top of that, I think a lot of data science and a lot of the questions that have come in really connected to what actually happens when you build things and you have to actually get them to run with data that ultimately is about people. And some of the things that go in about legacy systems. This is something that we can't shy away from. And whether you're working in the academy, you're working in industry, or even in public sector. The systems will always have lots of legacy that you then have to deal with. And then on top of that, there's regulation. Then there's the ethical decisions that have to be made as we're building these models. And then, there's all this part that's very technical on dealing with on this part. Thanks everybody for coming through to our first talk. In this series, we will be having them, I think, almost every 3 weeks. The next one will be, I think, the third, in September. We will notify you. Just make sure you're subscribed to the newsletter if you're not, just to keep track of what's actually going on. I will just put it into the chat just to make it easy for everybody on there. I think most people are. And yeah, have a good Wednesday. Enjoy the rest of the day, and we'll see you at the next one. Thanks, Felipe.
Thanks, everyone. Pleasure.